The ESR Material Transition plugin helps you to create animations in your materials without the need for timelines or even ticking your actor to update the material. It can do things like this, where you have a flash useful for damage effects or activation feedback, or this, or you actually have a toggle, or this, which is something like a long press event, and we get an event callback when it's complete, or if we cancel mid-progress, we get the progress that was accumulated. And this one, which is independently varying a couple of different parameters and can be interrupted and animate from where it left off. So let's take a look at how each of these examples are working, as well as the contents of the plugin itself. The core of the plugin is this material function right here, and a couple of native functions inside this blueprint function library. And inside the example folder, here, you'll find this level, and a folder full of actors, and another folder with their corresponding materials. So let's take a look at this first actor, which is the simplest to set up. Basically, all we're doing is binding to the overlap event of this trigger box with this event that fires off this function right here when it's overlapped. And this is part of the function library that comes with this plugin. Basically, all you need to do is set the duration, a start value, and an end value, and you name the material parameter, which is going to be a vector 4 inside the material that you author. Let's take a quick look at the material that's on the sphere that blinks here. Basically, this is the entire material here, and this is the material function that comes with the plugin. You feed it the values for your vector 4 that you named, and out of it, you receive either the value between the start and the end, or a normalized value that ramps from 0 to 1 as the animation progresses. So the result of that is this blinking sphere. Beyond that, we have this toggle here, which is actually storing some state, whether it's toggled on or off. We can see we're doing the same thing here where we bind to the overlap event of the trigger box. And I might have mentioned before, but this is the standard way to create a dynamic material that you can change at runtime. We're just creating the dynamic material instance off of the sphere, the index 0, and then catching a handle to it. And in here, we're also checking to see if the component that's triggering this is the root component of this other actor. This helps prevent multiple triggers from firing off quickly when the actor has more than one component attached to it. So here, basically what we're doing is setting the toggle to be the opposite of what it was, and selecting a start and end based on whether it's on or off. And we ramp over 2 seconds to the transition params variable. And this one, you may notice, transitions nicely, but is a bit of a naive implementation, where if you re-interrupt it before it's done, it will start from the opposite side and ramp from all the way off to all the way on, or vice versa. Whereas this other one right here has a bit more of a sophisticated implementation that we can actually interrupt, and it will ramp back down from halfway or back up from nearly gone without popping to the opposite side. So let's take a look at how that one is implemented. This one, again, we have the toggle state as a variable, but we also have the current progress here. And we're calling a different function from the Blueprint function library, which is this transition scalar parameter stoppable. This one will actually return a cancelable async action that we can cache a handle to and bind to events for completion and cancel. So we're doing the same setup as the other examples so far, where we're binding to the overlap event, checking to see if the root component has overlapped the trigger box. But then, first, we're checking to see if the async handle is valid. It'll destruct itself once it's done its job. And if it is currently in progress, this variable will be populated and we can cancel the event, which will then fire off this callback here, which provides us with the current value that it's reached, the normalized fraction of the progress, and the time that is elapsed in the duration that we set here. And off of that, we can cache the current progress so that each time we start this event, we start it from wherever the current progress is to the target value for either the true or false state of that toggle. And in the onCompletion event, if we let the toggle run all the way to the end, we simply set the current progress at either the full value or the empty value. So that's it for this blueprint. Let's take a quick look at the material on the sphere. And this is the same material for both of these toggle examples, where we're scrolling some noise by its world position and remapping the value range out of it to get this sort of swirling cloudy effect. But then all we're doing with this trigger ramp material function is either ramping up or down. And if it's greater than the threshold of the noise, we set the opacity to 1, otherwise 0. And we just use this color that is also sort of on or off for the emission based on the value of the trigger ramp. So next up, we have this accumulating sort of progress bar. And this one, the events here simply print off these values on the cancellation, and on complete, it just sends this message transition complete out. The thing that's different about this one from the previous example, besides not storing the current value, is that we also bind to the end overlap function of the trigger box. We're still checking to see that the overlap component is the root component. You might also want to check if it's the player's pawn or not, or various other things depending on your use case. But if we are the root component exiting the box, then we send off this cancel event at that time rather than on each new overlap. And that will cause the progress of the material transition to end, as well as printing off the values from these outputs right here. And our final example of this sphere that transitions between multiple material parameters, we're using this other material function that is in the main folder of the plugin content, this auxiliary parameters, which allows us to set more parameters to be animated alongside of a single scalar that would be animated with the first function library function. So let's take a look inside the blueprint here. This one has the same setup, where we cache the dynamic material from the sphere here. And then we bind to the begin overlap event. When it's overlapped, we check to see that it's the root component. And then we're doing the same thing where we're calling upon the cancelable version of the transition function so that we can cache the cancelable async action off of that. Back up here, whenever we overlap, the first thing we do is check if there is a transition in progress, and if so, we cancel the transition to grab the current values before starting the next one. And then when we actually do start the transition, we have this function here, which is picking randomized ranges for the metallic and roughness parameters of the material. We're sending it through this function from the library, which gives us the start and end of two parameters that are bundled together in one 4-vector called aux_params. And then after that, we pick a randomized range for the hue and send that in along with whatever the current hue value is to start. And then whenever the event actually completes or is canceled, we're again setting the current values based on whatever the target values are. Let's take a look inside this function here that's used both in the complete and cancel. We get the proportion of completion from the callback, and then we can set the current value for either metal or rough based on its interpolation between the start and the end. And this function over here, which is picking the initial randomized ranges, is also using the current value for the start and a random for the target. And we just return all 4 of these values here and set them on the auxiliary parameters here. Let's take a brief look inside the material for this as well. And this is the whole material, where we can see we have a 4-vector for the auxiliary parameters and the 4-vector for the initial scalar that's driving everything. So off of the material function for the scalar ramp, we're using the normalized value to drive this sigmoid curve, which adds a little bit of easing to these other values. And basically using this other material function from the plugin to interpolate those, set the metallic roughness and this world position height off of the value that's being used for metallic. And we're using this hue shift node just to kind of loop around the hue circle here as the scalar is changing. So that gives us this.